Okay, I think I'll get going here. I'm sure there'll still be a couple of late joiners or whatnot, but thanks everyone for joining us today for the August meetup for Cloud Native Madison. Obviously, we took last month off, and we'll go on out here till I guess we'll be virtual probably until the end of the year this year. Brandon and I really haven't decided that for sure, but I think it's a pretty high confidence that we're going to go virtual here for a little bit. So just a reminder, everybody, you're probably already coming in muted, but stay muted if you can. Feel free to, if you want to unmute for a second to ask a question, that's fine as well. Or you can just throw questions into the chat. And we'll watch that as we go along as well. Sponsors, today is Integral, although I probably should have put Dynatrace on today as well. But Integral is sponsoring basically the meet up and the recording and giving Brandon and I time to put this on during the day and get this all prepared and put out the YouTube as well. So, other business. Next meetup, we still don't have a speaker. It will be online again, like I said. It'll be September 3rd at noon again, Central Time. If anybody is looking to give any sort of presentation, please contact either myself or Brandon. You can do that through the meetup site or directly, whatever you prefer. We want to get that announced here relatively soon. We like to have it announced ahead of time, like during this one, but didn't quite get to that. But hopefully within the next couple of weeks, we'll understand who that next speaker is going to be and what the topic is. One of the things, with the vacation that we had from the meetup last month, and I took a personal vacation last week, I read a book, Start With Why. And it sort of inspired me to sort of go back to the roots of when we started up the meetup about a year and a half ago and really start thinking about, why we're putting that on. And even more broadly, why does the Cloud Native Computing, Foundation exist? Obviously, that goes into, why we exist, and even deeper, why do we really love doing what we do? And, as engineers, and, working with software, cloud native technologies and whatnot. And, some of us, it might be about, career growth and stuff. And, that's great. Some of us, it's, maybe we're in our own, businesses, starting up and, really want to accelerate our businesses. But I think, a lot of us, it's really about that love of serving the customers and whatnot. And so ultimately, what we want to put on here, within this meetup, and I think, within the Cloud Native Computing Foundation, in general, is just to be able to provide, technologies, out to our fellow developers and even to ourselves that ultimately transfer into a great experience for the customers that we have, that are using our software and the users and whatnot. So everything that we try to do, as a community, we should sort of bring that into, what we do, our presentations, our speeches, and, the technologies that we put out there, to keep that sort of in mind. So, really that, thinking about that why. It's an interesting book if anybody, wants to read it. It's by Simon Sinek, I think is how you say his last name. It's at first, if you're a little off put by Apple Technologies, I think you could also rename the book, why every company should market like Apple. Little cynicism there for me. I'm not a huge Apple lover myself, but at the same time, he goes into, make it a little more emotional instead of just, always being very logical in your, starting with those features or whatnot. It's not really about the features all the time, making an emotional connection, and then ultimately, it'll help with your products going forward. So just a little side topic I just wanted to bring up, but yeah, I think it helps keep us grounded in terms of our meetup here as well, of bringing that into the topics and the presentations that we bring in here. And with that, I'll transition over to Jürgen. I was going to try to say his last name, but I'm going to let him say it himself. But Jürgen is here today to talk about overcoming scaling issues with your Prometheus ecosystem. Jürgen works for Dynatrace, and he is a founder of the Keptn project, which helps use metrics in your CI/CD pipeline. But I'll let him speak more about that. Jürgen, it's all yours.
Cool. Thank you, Kurt. Let me share my screen, my entire screen. Why not? This one here. Okay, so you should be able to see my screen. I switched to my slides. So I do have a couple of slides. I also do have a short demo prepared. So yeah, hopefully the demo gods are with us today. As Kurt said, please ask questions in the chat, or maybe at the end of my presentation, we have a little chat and we can discuss what you think about the solutions that I was presenting during the talk, or I will be presenting. So it will be about overcoming organizational scalability issues in your Prometheus ecosystem. And as I was introduced, that I work for a company called Dynatrace. We are, let's say, a big vendor in the APM space, application performance monitoring. Also, we have our AI solution with we tackle the whole software intelligence stack. But why am I actually then talking about Prometheus if we have our own product? It's because I am heavily involved in a new open source project called Keptn. And I am from Austria. It's right next to Germany. We speak German, and for us, Keptn actually really sounds like captain, like the captain of a ship. And that's also a little bit of the background of the name. Then it's spelled with the K, so for Kubernetes. We think it's a good name, and it's kind of funny. And we will touch it some nautical terms during this presentation. So if you like this, that's nice. If not, just that we just made up a couple of words that kind of make sense in the terms of in the context of the project. So yeah, I put in here some links, and I can also share the slides afterwards. It's a Google slide deck, so I'm happy also to share this with you. So what I want to actually do today with you in the next, I don't know, like 45, 50 minutes, to talk a little about the challenges that we have discovered when we as a company and as an organization have talked to our customers that are already using Prometheus, which challenges they are seeing and they are facing. And I want to propose solutions to overcome some of those challenges. And I would also like to learn from you, what is your solution for these challenges, or which tool stack are you using? So if you want to add your comments in the chat, or afterwards if you want to reach out to me on Twitter, LinkedIn, I also put links for this here. So let's get started with what I actually want. I don't want to do all this configuration. I want to have like my running system. I want to have my dashboards. I want to have my alerts. I want to have monitoring set up as easy as possible, because this is not the fun part where you really have to tackle this for each new workload all over again. So basically you want to have this in an automated way. But this is not where we can start, because usually you don't have any automation set up. And this is our goal. We want to reach this goal. And for this, we kind of take a short journey. Where do we start? What are basic building blocks for this, also to set the ground for this presentation? Then we will tackle 3 different challenges. And I will talk a little bit about Keptn as an open source tool that can solve these challenges. Actually, it was not intended to solve these challenges at its core, but it's kind of, we are solving these challenges because we're doing something bigger, and one part of our journey of the purpose of Keptn is then also to solve these challenges. And I also read a short article on this, so if you want to read it instead of like listen to a presentation, you can also go to Medium and take a look at this article. So where do we start? It's a very simplified picture, but usually you have an application cluster with Kubernetes, and Kubernetes is like managing all your pods on it. They are exposing the endpoints via the metrics, the metrics via the endpoints, and Prometheus is kind of scraping them. And you might have more than one application cluster. You might also have more than one Prometheus cluster. For today, I'm not tackling so much how you can scale Prometheus, because that's like from the technical perspective, how you can make it high availability. There are other projects for it. I know from others, they are using Tanos or Victoria Metrics or some other solutions, but there are other solutions out there that really tackle this from a technical perspective to make a high availability and high scalable setup of Prometheus. We are more talking about how to tackle the needed configuration for all your workloads and how you can overcome the scalability issues when you onboard more and more workloads to Kubernetes, and then to have this managed with Prometheus, and you have your Grafana dashboards ready for it. So challenge number one that we've seen for a couple of our customers and organizations that we worked with, they have already, or they have written their scrape jobs and alerting rules and recording rules and dashboard configurations for Grafana. They have everything. They already apply it to Prometheus with the kubectl apply, or with Grafana they import the dashboards. But after some time, there might be some issues because they are not sure if the configuration that they have just saved on their hard disk is actually the configuration that they have applied to the Prometheus, or if something else is running in the Prometheus. So they are not versioning their configurations for all those different kinds of parts in their Prometheus ecosystem. And one potential solution is to use not only GitHub or GitLab or whatever Git you're using, but really using it in a GitOps way, so that you're pushing all the configuration files that you're having, like the scrape jobs and the alerting rules and dashboard configurations, to push it to your Git repository, and then to manage everything in Git and have an operator that is syncing the Git repository then with your actual Prometheus installation. So you're not allowed to do any configurations, any configuration changes or edits in production anymore without pushing it first to Git and having, let's say, an approval. So everything that is, let's say, on master will be pushed to production, or everything that is in your production branch will be synced to production. But you cannot do it without any approvals, and you can always make sure that the file that you are seeing in Git is also the file that is actually applied in your as your configuration. So you really can, you have this power again that you know, okay, this is the configuration that's actually applied, and this is why I'm seeing this or that error. But then the second part was, okay, I now have my Git operator, but how to basically create all the different configurations. And it's not only one file that you have to write, but it's a lot of different files that you have to come up with. And it's probably also a lot of different, it's mostly two technical domains. The one is YAML, the other one is JSON. They are very, very similar, but still they give either the one or the other gives you headaches. So you might need some way to create all these configurations. So it's not only one, it's really a lot of configuration that you have to deal with. And I think one very good approach is to use code generators. And there are a couple of code generators out there, and I list a couple of them at the end of the slide deck in my reference section. So you can take a look. There are code generators for generating based on SRE practices to generate like SLO files, service level objectives, and error budgets, or to generate Grafana dashboards based on other input files. So there are a couple of code generators out there, and I think it's a great idea to use them, since they usually don't make any errors. So if it's a mature code generator, then they generate the right output files for you, and you just have to feed them with the input data. And then you can just store whatever the output is in your Git repository, and then you still have the rest. So we kind of building upon the previous solution, and we can just add code generators here. But another thing that we have seen is that these code generators, they tackle one specific problem, and then they generate the code for this one specific problem. Then you have to tweak it a little bit, or sometimes the input for the code generators is also very different. For the dashboards, you feed the dashboard code generator with other data, then you feed the code generator for your error budget and your alerting rules or your scraping jobs. So the input is different, and this might be the reason that these configurations, they might drift out of sync during time. So they might be like this. The input might be the same initially, but then some folks, they feed it with other data and they generate the files, and then you put it to your Git repository. So there might be some dashboards with alerts running in your production, but maybe your alert manager had some different input files, so there might be this might be configured in a different way. So this is, I just want to say, you have to be careful when you're using different code generators and feeding them with different input data. So what we are suggesting, or what one solution could be, to find a way to base the input data on one well-known or like established concept. And we found that the last years it has shown that the SRE community is really strong and has established concepts for service level objectives, service level agreements, service level indicators. So all these concepts they have came up with, you can use those, and with this you can then feed your code generators, because let's say the service level objective holds a lot of information, although it's very easy to understand, but it will hold a lot of information. Which service, what is my objective, which data do I build my objective upon. So they have a lot of information, and you can use it, then you can feed this data into your code generators. And with this, you can really define what you want, and you don't have to take care about so much how you want to do it. In the beginning, we started with writing scrape jobs and dashboard configurations in YAML, and now we can write what we want to do, and we have all this code generation with everything, like just after pushing the button, we have everything automated. That's like the idea. And this is also a little bit what Keptn is doing. So I want to introduce a little bit of Keptn, this open source project that I'm involved in, and how we can automatically configure Prometheus in Grafana, and how we can also use this configuration, all the data then from Prometheus, to automate quality gates for continuous delivery, and also automate operations. For the last part, the automated operations part, I will just talk very briefly at the end, but the other two parts, I try to explain them in more details. So the Keptn way is really to abstract from all these implementation details, to feed Keptn with the data, and then have Keptn acting as the code generator, have Keptn acting as the kind of operator to apply the rules to your Prometheus or Grafana instances, and have Keptn also as a Git repository. Keptn has its Git repository internally, where you have all the GitOps way baked in, let's say. So at this point, I've already thought it might be a nice time for maybe a short demo. So let me switch to my Grafana. It's like in Grafana, we can see the most things. So I thought it might be a good start into the demo. So we can see it's a fresh Grafana installation. There are no dashboards yet, but what I do have is I do have an application already up and running. It's a very simple sock shop application where you can put your socks in a shopping cart. Yeah, that's basically the only service I've deployed in this demo scenario. And I have Keptn also installed in the cluster. So Keptn is a control plane that is running in a Kubernetes cluster and can react on different events. And I do have my, where do I have it? Yeah, I do have my CLI here. I do have my Keptn CLI, and let's just let me find the right command. Here we go. So what I want to do is actually, I want to start configuring my Prometheus installation for my project, which is the sock shop, and for my shopping cart service. And with Keptn that is living in my Kubernetes cluster, I can just send this event. And I have to say, I've previously onboarded my application that's with the name sock shop and a microservice with the name carts. So Keptn already understands this command. And I will also show you a little bit of the files that Keptn is using here in the background. There is one SLI file and one SLO file, and probably take a look here on the SLO file, because that's only the description about a quality gate, but we can also use the quality gate for CI/CD for using it to generate alerts. So if we are not passing the quality gate, that's actually a bad sign. So we can also use it for generating alerts. I'm also using it for generating the dashboard. So let's take a look if Keptn did the configuration for us. We should now be able to see a Keptn dashboard. So I just called it Keptn dashboard. It's the Grafana integration of Keptn. It's quite new. It's still in development. So we just released the very first version. But what we can see already here is that data is coming in. So it was not only configuring Grafana, but it was also actually setting up Prometheus. So I should do another port forward to my Prometheus installation, and we will see it's a fresh installation because it was not running. I removed it before, so I will see there is Prometheus running. I should see there are a couple of rules, or it's just one rule. I should also see there are a couple of scrape jobs defined here. And it's interesting to see there are scrape jobs for sock shop dev, production, staging. And that's the reason, because I set up my environment as a multi-stage environment. So I have the same microservice in 3 different stages. So I can control which version I want to promote to production, and the other versions are kept either in staging or in dev, depending if they can satisfy the quality of the quality gates that are between those stages. I will explain this also in a minute. So yeah, we can see Keptn kind of did its job. So it was creating different dashboards for me. I get out of the box a dashboard for the response time, the throughput, the error rate. These 3 are usually called the red metrics, and like the standard metrics you might want to have for your microservices. And I do have them for production, staging, and dev. They look a little bit different since it's 3 different stages. And there is a little bit of traffic running or going on in the background. There are no errors, luckily. But yeah, that's how you can really easily generate dashboards for one microservice. And you can re-execute it for other microservices. So you can just generate your dashboards and your scrape jobs and alerting rules for Prometheus. I showed it just this one command, but basically, the whole magic is just this one command, and I will explain how it actually works and what Keptn is. So let me continue here. So Keptn, in a nutshell, is really an event-based control plane for continuous delivery and automated operations. And that might be a lot of buzzwords, but it's actually true that it's event-based. So Keptn is this control plane where we just send events, and so you send events to Keptn, and Keptn will send out events. All the events coming to Keptn, coming from Keptn, these are based on cloud events. That's also a CNCF project, and I would say more or less maybe already a standard protocol, how to send different payloads. So we are using cloud events, and we put all the data we need inside these cloud events. And we can control continuous delivery, and we can also automate operations with this sending and receiving from cloud events. So a very simplistic workflow is sketched here, that we have, for example, a service responsible for deployment. We have a service responsible for testing. We have a service responsible for validating. And then eventually we have a service responsible for remediating if something goes wrong. So you can read it also from the left to right. And Keptn has this workflow already baked in. So the control plane has a kind of baked in logic. Whenever there's a deployment, the control plane will, as a next part, trigger a testing tool if one is connected to the control plane. If there is a testing tool connected to the control plane, the test will be executed. After the tests are executed, it will send an event to Keptn, to the control plane. Keptn will reach out to the validation tool. That's a baked-in service. So Keptn will do the evaluation of the tests. And if it was successful, Keptn can reach out again to a deployment tool and deploy it to the next stage, or reach out to the deployment tool to, for example, roll it back to the previous one. So this is kind of the workflow and idea of Keptn. The architecture from a conceptual point of view is that we have the control plane living in your Kubernetes cluster, and we have a lot of services that we can connect to this control plane. And we also have our environment definition, and that's our shipyard file. And this environment definition does not talk about tools. It just talks about which environment you want to have, which kind of deployment strategies you want to have in the environment, which kind of testing strategies you want to have. So it's completely unrelated to the tool set. The tool set is defined in the Keptn's uniform. That's basically defining what is the Keptn, like which uniform is the Keptn wearing, let's say. So that could mean for testing, it's JMeter, for deployment, it's Helm, for observability, it's Prometheus, for dashboarding, it's Grafana, for the GitOps way, it's Bitbucket or GitLab or GitHub. So, but the environment definition, which stages you have, which deployment strategies you want to do, this is kind of loosely coupled. And with Keptn, we provide already out of the box a lot of different services. But since it's only cloud events coming to these services and going from the services, you can integrate basically any tool as long as you have this translation between a cloud event and then the instruction in the tool. So what I did for this short demo, and what I'm kind of have been working on, is to provide this Grafana integration. So I'm just receiving an event from Keptn that the user wants to configure Prometheus as a monitoring tool. And since Grafana and Prometheus are, I would say, like strongly related, I also listen for these kind of events that for configuration events for Prometheus. And if I can do something with those events, like creating dashboards, then I just send out the API calls to Grafana and configure or create the dashboards. So in this case, I can just listen for different kinds of events and then act upon those events. And yeah, as said, there are different tools that you can just connect to the control plane, and they will act depending on the type of cloud event. Keptn has defined around, I think right now we are like 25 different kinds of cloud events or different types. So there is one type for starting the deployment, there is one type for starting the tests. And for starting the tests, obviously, you would have a testing tool connecting to this event and then reacting on this event. But we also have services that listen for more or less all the events. And these are like Slack notification service. You might want to listen for all events and just pushing it into a Slack channel so that the user knows what's going on inside Keptn or inside your cluster. The user can just follow along the cloud events that are coming from Keptn, like, hey, there's a new deployment triggered, now the tests have been triggered, or the evaluation was done, but unfortunately not successful. So the developer can already see, maybe it's his service, and can already see, start with bug fixing. So this is the idea and conceptual architecture of Keptn. I also mentioned that Keptn builds upon SRE best practices, and we are heavily using service level indicators and service level objectives. The indicator is basically a metric, some data that you can evaluate, and the objective is the goal or the threshold that you are evaluating it with. So, for example, the login rate must be less than 2% within the last 10 minutes. So this is, you already have the indicator, that is the login rate, and you have the objective, that is the 2%, and you also give it a time frame so that you can evaluate it. We already have a couple of metrics defined that come with Keptn. So we have like a library of SLIs, and the red metrics are already included in this library. We've done this for Prometheus and Dynatrace already. If you come with your own monitoring solution, or you're using some others, then you just have to write your service that knows how to fetch these metrics. Basically, you have to know how the API call to the data provider looks like. So how can we then map the service level indicators to the service level objectives? It's basically the SLI file, we call it, defines all the indicators. And in this case, we can see the error rates, the number of database calls, the response time. There might be more, there might be like hundreds. And it's defined by like the key, and the value is just the API call, how to retrieve it. The power of the separation, having indicators and having objectives, is really that you can easily then reuse the indicators in your objectives file. And if you ever want to change the data provider, or you have different data providers for different stages or for different projects, you can still use the same service level objective files. That's a pretty cool thing, because there might be like a very similar project you're working on that you want to just reuse the objective files, but you can just exchange the indicator file. Or if some API versions change from version 1 to version 2, you just change it once in your indicator file, and you don't have to change it in your objectives file. And for the objectives, you can define some criteria, either relatively or absolute to the previous runs. And once Keptn is triggered, like the Keptn control gets triggered to start an evaluation, you can do this either on demand, or Keptn will automatically always trigger an evaluation after a new deployment and after the tests for this new deployment have finished. So you can start this evaluation. I'm sorry, the evaluation use case, I just see it in the slides. I will talk about in the next slide. Here, I'm just highlighting how the configure monitoring command I was just demoing, how this is using these files. So I was sending this Keptn configure monitoring Prometheus command to the Keptn control plane. Keptn was distributing this event to all those tools that were listening for. In my case, it was Grafana and Prometheus, and no other tool was listening for this. And then my services, the Grafana service and the Prometheus service, they interpreted this in the way to send out the right API calls to Prometheus and Grafana. And they were generating my alerts, my scrape jobs, and also my Grafana dashboards. So in this way, you can connect more and more tools, and you can make sure that everything they do is based on the same configuration. And we can reuse these files, and that was actually the main purpose when we started Keptn, that we want to have this kind of quality gate that we can reuse during continuous deployments, but also when we're running in production, something goes wrong, and we try to do some remediation actions on it. We also want to evaluate, did it work, did it work? So we can use these Keptn quality gates by just sending the evaluation start event to Keptn. Keptn will then query all those SLI providers. So it's basically, Keptn will take a look at the SLI file and the configuration, which tool is actually connected, and will then reach out to either Prometheus or Neoload or Dynatrace, and will fetch the data, and will bring back this data to the quality gate, and the quality gate will take a look at the objective file and will then come up with a score. So whenever it's passing, you will get full score. If it's within the warning criteria, it will get 0.5 points. And if it's neither passing nor a warning, it's a failing evaluation, it will get 0 points. It will score the whole quality gate description, so it can be more than one objectives. We'll come up with the total score. And then you can either even define the total score. If it's higher than like 90%, it would be a pass. So actually, I just see that in my demo, it's not matching. So it would be like, if it's higher than 80%, it would be green. If it's lower than 80, but higher than 75%, it would be a warning. If it's less than 75%, it would be a failed evaluation. And then the next tool in the tool chain can react on this. And like for a failed evaluation, it can roll back the version, or it can trigger the next remediation action. Just depends on the use case. So there are a couple of files, as said, included in this, in the way we think about continuous delivery pipelines, and also using all these files for automated operations and configuring your observability tools and dashboarding tools, so you can really then scale the whole thing, since it's just one API call or one CLI execution to onboard a new service to Prometheus and Grafana. So the first thing is you will create a project with Keptn based on a shipyard file. Again, here we have this kind of ship or nautical terms. So the shipyard file really defines how many stages, which kind of deployment strategy, which kind of test strategy, which kind of approval strategy, which kind of remediation strategy. These kind of things are defined. Keptn will then go ahead, will configure its internal Git repository, will put the shipyard file into the Git repository, will create all the different branches for the different stages, so that we can always make sure the configuration is stored in a GitOps way, and you can always take a look what is actually going on in your cluster and what is actually managed by Keptn. So Keptn will create the staging and production environment. You will then onboard a service. That means you will give Keptn a Helm chart, and Keptn then knows how to deploy, or will reach out to Helm, or will use Helm to deploy your services, either in a direct deployment, that means by replacing the previous version, or in a blue-green deployment, that means having the previous version stand by to your to the new version, so we can immediately flip the traffic or switch the traffic from the new to the previous version without any downtime. You can then use Keptn to configure the monitoring service. As said, it will use the files like the SLI and SLO file and the shipyard file that you already onboarded and committed to Keptn. And Keptn can also be used then for continuous continuous delivery and with baked-in quality gates. And that was actually the starting point when we started to develop Keptn. How can we make the best practice of continuous delivery with automated validation? If the quality is satisfying, how can we make a framework where we can connect whatever tool we want? So in this case, we're just telling Keptn to trigger the deployment for a new version. And as said in the beginning, Keptn will first do the update of the Git repository, will then apply this update in a blue-green deployment fashion in this case, will then start to trigger the tests. So also the testing files, the JMX files, for example, you add them to Keptn. So Keptn knows which files have to be executed and to which tools to reach out. So they will be executed after the tests have been finished, and Keptn knows when they were started and when they were finished. So Keptn knows the time frame where the data has to be evaluated. It will reach out to the data provider. It will score the data and will decide if it should be promoted or not. And the exact same workflow will be repeated for the next stage. If it's production or if it's a pre-production stage, it doesn't really matter. It will be the exact same workflow. If there are no testing tools connected in this stage, it will be just skipped. For production, for example, you might want to do so you might want to skip the test since you have your end users anyway that are basically doing, let's call it testing, but they are using your product. So if something goes wrong, you should be able to see it. Still, Keptn can do an evaluation after like 10 minutes running in production if everything's fine, and then you can decide if you want to keep it, roll it back, or send out some notifications to Slack, MS Teams, whatever tools you're connecting. So this was like a very fast and rough overview how you can use Keptn to overcome some issues in your when scaling Prometheus in the sense that you're onboarding more and more workloads, but also how Keptn actually works and what Keptn is built for at its core. So we have contributions for Keptn that for example, the Prometheus service and the Prometheus SLI service. One is really responsible for configuring Prometheus. The other one is just responsible for fetching all the metrics from Prometheus and providing it to Keptn. And then we have a new service, which is the Grafana service, responsible for managing the Grafana dashboards. But there are a lot more services, like a Slackbot service, like integration with JMeter, with Neoload, with what else do we have? A couple of more. Maybe I've listed it somewhere else. But we have a growing ecosystem of services that are taking data from Keptn and then acting upon this data. So as said, I've listed also some of those code generators I was talking in the beginning. I listed some of those here. If you have some code generator that you are using, I would be happy if you would send me just a short notification here in the chat, or later on Twitter, or via email. I would be happy to add them here. And yeah, Keptn is an open source framework. If you think this is something that's interesting and like solving a problem also for you, then also please go ahead and check it out. Our website is keptn.sh. The whole project also lives on GitHub, so you are able to fetch the Keptn CLI here, and with the CLI you can do the installation. We have a growing community. If you want to be part of the community and like get in touch with the developers, this would be the starting point. Oh, sorry. And yeah, we have other resources to get in touch with the Keptn team. And with this, thanks so much for your interest in Keptn, and I'm happy to answer some questions.
You're gonna like this talk so much I had to bust out my captain's hat.
Oh, cool. I didn't see what I was presenting. That's so awesome.
So yeah, this is really cool. I was curious if you could talk a little bit more through the mechanics of how those progressive blue-green style deployments actually go out. Is it just pure Kubernetes resources with shuffling around label selectors, or how are you guys achieving that?
Yeah, actually, we are using Istio behind the scenes for the blue-green deployments. Keptn is actually, when you're onboarding a service with, maybe I have it somewhere in the slides. I'm afraid I don't. But so when you're onboarding a service with Keptn, it's kind of indicated a little bit here, I guess. You would provide a Helm chart, and Keptn will take the Helm chart untouched and generate a new Helm chart out of it with virtual services. And Keptn has, for the continuous delivery workflow, Keptn will manage its own Istio in the cluster. So we are creating virtual services where we can then, for blue-green deployments, we just set the weight of the routes then to 100% or 0%. So we do the blue-green deployment with kind of traffic shifting between 0 or 100%. But it was already the first step to also support canary deployments, because we have the Keptn quality gates where we can do evaluations for every iteration. So we can then do like a 10-90 distribution, and then like a 30-70, 50-50, and then just increase it maybe to 100. So this was the reason why we chose to go for Istio at the very beginning. Where we also have the integration now is with Argo CD and Argo rollouts. And with this, there is no need to manage Istio anymore in the cluster, because we just rely on Argo to do the deployments. And yeah, so with this, we don't have to, there is no need for Istio anymore. That was one of the drawbacks that some folks didn't like, more complexity added to the clusters. And some folks, they are also using, interestingly, they are using Keptn as the control plane, and then they connect their old Jenkins pipelines for the deployments. So they are not using Jenkins for doing the orchestration between the deployments and the testing and the evaluation, but they still use the deployment functionality of Jenkins to trigger the deployments. And once the deployments are done, because they have everything already configured, once the deployments are done, then they send back the event to Keptn, and Keptn will then trigger the tests to the evaluation and these kind of things. So it's, yeah, this is how we do it.
I really love the design around, you know, utilizing other tools and just having those integrations to those other tools. What does it take to set up, you know, for a tool that you don't support right now, sort of a connector to, I mean, I said, you know, you said you went through the cloud events, so I'm assuming maybe it's just connecting to those events or whatnot.
Yeah, so we do have the, I think it lives in the Keptn sandbox. Let me take a look. So let me just go to the Grafana service. Can you still see my screen?
Yes.
Okay, so we do have a Keptn service template. So with this service template, we've written it in Golang just to make it, like, we thought it's maybe one of those, like, let's say, cloud native languages, and a lot of Keptn is also developed in Golang. So we provided a service template. And it basically, to get started here, you would just use this template or clone it, or just use it. And then the only thing, I'm not sure if it's written here, but it basically already has a matching between each cloud event, or the type of the cloud event, and then it has just a placeholder for the action you want to take. So if you want to take this, you would just go for, maybe it's in the event handlers, I think. So it has all these event handlers already here. And if you just want to handle like a start evaluation event, you would just put your logic in here. So what I did for my Grafana integration, I used this template. This was provided by our core development team. And I just did, like, where it says, I'm not sure if I can find it, but where it says handle configuration, monitoring configuration event, then I would just doing the Grafana API calls here. And then we have another service that is doing basically the same logic for Prometheus. So this is how it works. We also have other integrations from the Keptn community. Interestingly, one of them is writing his integrations in PHP. So he's using PHP, listening for the events, and then just doing some of his PHP magic. And we have some of integrations written in Node.js, I said PHP, Java, obviously. So it doesn't really matter which language you're using. We like to go with Golang because it has also the libraries to handle all these cloud events, and you don't have to parse the JSON. You can just use the libraries for the cloud events, but they're also available for Java, I guess for .NET and other languages.
So what are the next big steps for the project in terms of where you're looking to improve things, add on, or looking for other people to help contribute to the project?
Yeah, I think there are different threads. So we have a couple of partner companies we're working with that are providing more and more functionality to Keptn as it is. So for example, we have Citrix. They are working on a Slack bot. So they want to control Keptn via a Slack bot and not with the CLI. Again, it's the same thing. You would just send and receive cloud events from Keptn. So we have like the ecosystem growing with more and more integrations to Keptn, but Keptn itself will also be improved. I was explaining there is the Keptn workflow where it's really starting to the deployment, then the testing, the evaluation of the tests, and then another like promotion or rollback. But we are opening up for like a user-defined workflow, not in a way with Jenkins where you have like Groovy and writing the big pipelines, but just in a way that you are adding a stage, or you can add a phase to a stage. For example, a security screening. You want to do a security screening for your containers before you push them to production or before you start some testing. And right now, that would mean you have to subscribe to the same cloud event, and then two tools would be triggered. But we want to make this more user-defined, or we want to give the control to the user if there should be more stages or if there should be more tool integrations. And like I can just think right now of this kind of security stage that you might want to have. So this will be one improvement. The latest improvement we just made was for the auto remediation part, that Keptn is now triggering one action that is defined for auto remediation, like let's say scaling up or maybe wiping a temporary directory somewhere, and then doing the evaluation and then taking the next action and the next action. So in the previous versions of Keptn, it was more a fire and forget approach. And now we have really made it a workflow, a remediation workflow, where you just define which actions you want to take, and Keptn will make sure that these actions kind of get orchestrated, so that the first action will be executed. Afterwards, there will be an evaluation if the action was successful and these kind of things. So this is what we already included. The improvements in the shipyard will be coming in the next phase, and also we will there will be a stronger separation between the Keptn control plane and the Keptn execution plane. In the beginning, in the first version of Keptn, they were really closely tied together so that we could provide value really fast. But now that we are seeing there might be the need to run the Keptn control plane in one Kubernetes cluster and to run the application plane in another Kubernetes cluster. Right now, it has to be the same cluster, but we are already working on separating this, so you can have probably Keptn running even on small Kubernetes distribution like keys. So we are experimenting with running Keptn on keys. You can run it on a very small VM, and we just use Kubernetes as kind of a runtime for Keptn, and you can then, from outside, you can connect different services to this control plane, and you just have your services living next to your testing tools or next to your deployment tools, maybe. So in this case, we are trying to make it easier to use it.
You might have covered this and I might have just missed it, but you enable this on a like a service by service, type thing?
Keptn itself?
Yeah.
Yeah, so Keptn is, I think I have Keptn running here. So Keptn here is, let's say kubectl get deploy -n Keptn. We should find a couple of deployments in our Keptn namespace. So this is my Keptn installation right now. I have like my configuration service. I have a gatekeeper, which is basically promoting or rolling back or sending out a rollback instruction. I have Grafana, I have Helm, I have JMeter, I have a MongoDB data store, I have Prometheus. So these are all the services that are running and that are right now connected to Keptn. And
right. I guess I mean more of the services that we create. So if I have just a couple of microservices and I want to try the pulling the stats and attaching it to Keptn, I can do that with one service, not everything in the namespace.
Yeah. So if you want to connect Keptn to use the Keptn quality gate, you would just install the Keptn control plane in your Kubernetes cluster. It will be like Keptn install with the Keptn CLI. And then with the YAML configuration, you connect it to whatever tool you would need. So if it's Prometheus, you would need one service for Prometheus. If it's Dynatrace, you would need one SLI service for Dynatrace. Does that answer the question?
Yeah, I'm more talking about the services that we develop. So say we have like a user service and some other service in our own namespace.
Got it. Okay. So yeah, they are not living in the Keptn namespace. So I just have them living in, if I do a kubectl get namespace, I will see that I have SockShop running here in 3 different stages. And right now, Keptn is also managing this on the same cluster. It's not the same namespaces, but everything is on the same cluster.
Yeah, it's in the same cluster, but say your ShopBot, I don't know how many services you have in there, but say if you have like a invoice service versus a shopping cart service versus some other service, you enable it for all of those services, or can you do it for individual ones?
You could do it for individual ones. It's just in my case, I have 2 different deployments here, and both of them are managed by Keptn. So the carts DB is obviously the database, and then I have the carts. We have, unfortunately not here, but I have also one demo cluster where I have the whole Google hipster shop, which consists, I think, of about like 10 different microservices. I have it running all managed by Keptn, but I could also add some of those or some other microservice that is not managed by Keptn. But then you have to do all the deployments and like updates by yourself, and yeah.
Right. Yeah, I'm just looking from a transition standpoint. If you have all your stuff going on one CI/CD, to bring it into this, if you can do it, incrementally.
Yeah, got it. Yeah, totally. Yeah, that's also that's an interesting question, because that's also what we are seeing when folks are trying Keptn or getting started with Keptn and they don't know yet their SLOs. They are trying with the first services, and then they're usually trying with relative thresholds, because then they know if there's any regression coming in with the tests. And once they did 1, 3, 4, 5 deployments and the evaluation of the quality gates, then they know which what is the actual, what should be a hard threshold for the service. But it's with relative ones, it's easy to get started to find the to get a feeling about the actual data or the actual quality of the service if you don't know it yet.
Yeah, that's great advice there. Yeah, start off that for a little bit, and then you can sort of back into what it actually should be.
Exactly.
Okay, so we're coming right up to the top of the hour here. Does anybody else have any questions? Okay, well, I thank you a lot for your presentation. It was excellent. I know I learned a lot. I think everybody else did. If people do want to see the slides, we could put them on the Meetup site. If you said you had them in the Google Slides, we do that.
Sure. I think here is a chat. I can also post it here if you want to see it right now. Otherwise, yeah, please do post it on the Meetup group. I think I'm not sure if the spam detection sometimes is quite strict that I can do it, but yeah, you can.
Yeah, I'll try to post it out right onto this on this Meetup itself in one of the comments, and it should work from there. So if people want to see that, they can do that. So. Thanks once again, and we'll see you all again next month.
Thank you. Thanks. Bye.
Thank you. That was great.